Our final section in Chapter 9 is talking about the volume of pyramids and cones. So we talked about the volume of a cylinder and a sphere in the last section. Now we have the equation for volume of a pyramid, which is 1/3 times the area of our base. And remember, the base of our pyramid is that square shape on the bottom, the flat surface our pyramid sits on. And then times our height, which is the line from the point straight down to the middle of our base. Straight down the middle of our pyramid, that is our height. Okay, so in our first one, if we have a square-based pyramid, the volume is 1/3 the area of that square, which we can write as s squared. That is the area of our square. We have both sides are the same, and our height is straight down the middle. If we have a rectangular base, it's very similar. Instead of our two sides, we're going to have our length of the base and the width of the base, and our height is still the same measurement. It's still that line straight down the middle of our pyramid. So if we go back up to our square pyramid, if we said that our side was 5 centimeters, and our height was 10 centimeters, we could plug these numbers in to our volume equation. We would get our volume equals 1/3 5 squared times 10. Plug that into your calculator and you get 83.3 centimeters squared. Cubed, sorry. Volume cubed. For a rectangular base, if we said that our length was 10 inches, our width was 15 inches, and our height was 20 inches, we could plug these in. Our height is still right in the middle there. Volume equals 1/3 10 times 15 times 20. Plug that into your calculator and you get 1,000 inches cubed. For our cone, our area formula is 1/3 the area of the circle. So if you look at this formula compared to the area of the pyramid, it's very similar because it's still the area of our base, and our base just happens to be a circle this time. So it's the area of the base, and our circle is pi r squared. That is the area formula for our circle. So we plug in that equation right there. Our final volume formula is 1/3 pi r squared times height. So our height is going straight down the middle of our cone, and our radius is still from the center of our circle to the outside. So if we were to say that our height was 12 meters and our radius was 3 meters, our volume for this cone would be 1/3 pi 3 squared times 12. Plug that into your calculator and you get 113.04 meters cubed. That's a meters cubed over there. Meters cubed. Okay? One more example. This says find the volume of the cone, and this time we are given our slant height, which is the edge of that cone right here. It's 14, and our radius is 19. For our volume equation, we need our radius, which we have, and our height, which we don't have. Our height is right here. But if we look at our information we have a right triangle inside of our cone, outlined here. And if you look, our 14 is our C, our long side of the triangle, and we have sides A and B as our legs. So whenever we have a right triangle and we're missing a side, we can use the Pythagorean theorem. A squared plus B squared equals C squared. When we plug in those values, we're missing our A, that's what we're looking for. Our B is 19 squared, and our C is 14 squared. Sorry, this 19 should actually be a 9, not 19. So if we erase this, we have a 9 here for R. So we plug in a 9 squared. A squared plus 81 equals 1681. That's 14 squared. We have A squared. We're going to subtract 81 from both sides. A squared equals 1600. And take the square root of both sides. We get x equals, or A equals, 40. So now that we have our A up here, we have our height. So we can plug in our numbers now into our volume formula. Our R is 9, and our height is 40. Plug that in, you get 3,391.2 feet squared.